going on, everybody? Hope you guys are doing well. Welcome back to another episode of JavaScript from our learning sessions. As you notice, we are starting a bit early today. Trying to get maybe a head start on this, and then have a little bit extra time for later on in the day. So last session we ended up completing ES6, so we got to learn some new functions and standardizations for JavaScript, such as the arrow functions, the modules, destructuring, and the use of classes. So moving on from those, we are now doing regular expressions, or in the world of JavaScript, these are known as Regex, Regex, or EXP, or Regex, whichever. But yeah, these regular expressions are pretty much being able to create patterns to help programmers like us match and search and replace text. And these expressions that we make are very powerful, but they might be a bit hard to read because we use like special characters to make these searches a lot more complex. So like uppercase, lowercase, numbers, special symbols, that sort of stuff. So we're going to we're going to be doing that, and whenever we look for these characters, we'll be able to search through strings and make replacements. So that's a really good thing whenever we're making like hard searches, when we're trying to search through documents and that sort of stuff. So it's good. Well, not documents, but basically searching through databases and on sites looking for items. It's pretty much like this, is where regex comes in. So yeah, so we have about 33 steps with that. We'll see how they are, because some of these lessons, as we noticed, they have intermixing of challenges, so we might get through half of it, depending on how much stuff is a lot more in depth and how much challenge of a challenge factor it is. But yeah, we'll be doing that. So if some of you may notice, I haven't been using a lot of my blue light glasses lately. I wanted to take a second to kind of share with you that I don't know if it was one of the girls or cats, but there's that, and kind of broke. So yeah, so I'll have to probably order something later. I guess. I mean, it's alright. It just, sitting in front of a computer all the time, you gotta protect your eyes a bit. So yeah, so now you get to see all that without having to use those. Of all honesty, I'm starting to just get used to not using them, but I know over time they'll probably damage eyesight, which is not good. But, I mean, what can you do? So, alright, we will move on. We'll switch to the actual screen so you guys can see. Right here. So, we've already did the basic JavaScript, 113 steps, ES6 with 29, and now we're on regular expressions, which we will have 33, as we've talked about, using the test method. Will be the first thing. So, alright. So, let's begin. Regular expressions are used in programming languages to match parts of strings. You create patterns to help you do that matching. So if you want to find the word "the" in the string, the dog chased the cat, you would use the following regular expression with a / the and another /. And notice that the quote marks are not required within the regular expression. So instead of having to explicitly define what you're looking for, you can just put them, in between those / and it pretty much amounts to the same thing. So we're going to test it here. So JavaScript has multiple ways to use regexes. One way to test a regex is use the .test method. The .test method takes the regex, applies it to a string, which is placed inside the parentheses, and returns true or false if your pattern finds something or not. So basically it'll run the test and it'll say, yeah, it's located in here, or no, it's not. So as we look up here, right, you can see that my regex is assigned to, the hello, to find the word hello, right? Well, in here, it is here, right? So when we define result and assign that to my regex, right, we want it to equal true, right? So we want to store that value. So how do we do that? Well, we would do this. So we would put my regex dot test, right? But so what are we testing it on? Like you have to define it, give it a string or value to look through and say, yeah, it's here. So how do we do that? So we'll throw it in here. We'll put the string in my string. So there you go. So now it's taking this, which is right here, right? And it's testing it to see if it is in this string. And it should, the result will be stored in here. So result will equal to true because it is there, as you can see. So we can test that by doing a console.log and just putting the result in, right? And it results to true. So it's there. So you can put that in if and else statements to say if, result is true, then, you could, do whatever. You can print a result that says yes, it's true, or if you use an else, it would be, false. So there you go. The test method. We'll probably have to obviously do this within practice a few times so we actually remember it. So we'll see how that goes. So we'll run the test. So we're at 3% already. Not bad. Last challenge, you search for the word hello using the regular expression hello. Okay. The regex search for a literal match of the string hello. Right. Here's another example, searching for a literal match of the string Kevin. So it looks throughout here, tries to find the word Kevin, and it's in that string. So this will test true, right? Any other forms of Kevin will not match. For example, the regex Kevin will not match the lowercase Kevin or fully uppercase Kevin. So it has to be literal matches. So be wary of that. So that will return false if we try. A future challenge will show how to match those other forms as well. So that way it'll find, Kevin, no matter what form it is, if it's, uppercase, lowercase, whatever. So complete the regex Waldo regex to find Waldo in the string. Waldo is hiding with a literal match. So we'll have to change this to find Waldo. Now remember, you have to make sure it exactly is spelled the way right here to make this true. Right? Okay, so using regexes like coding can help you look for the pattern coding in another string. Right? This is powerful to search single strings, but it's limited to only one pattern. You can search for multiple patterns using the alteration OR operator. So the operator matches patterns either before or after it. For example, if you want to match the string yes or no, the regex you want is /yes, and then you have this, pipe right here that represents OR, an OR expression, and then you have no. So you can also search for more than just two patterns. So this is pretty important. So instead of just having one or two, you can actually do multiple, right? So complete the regex pet regex to match the pets dog, cat, bird, or fish. So let's do that. So be wary in JavaScript when you're doing if or else statements and you're looking for stuff. It's a double pipe. That is the OR expression. Now in regex, how it appears, it seems there's only one pipe that I noticed. So we'll have to be aware of that. So let's try searching for dog. So that's not in there. Or cat, that's in there. Bird, right? Or fish. So since cat is located in here, this still should test to be true because we have the ORs. If this was an and, like if it has to have dog and cat and bird and fish, this would obviously be false. So that'll come out as a true. So up till now you've looked at regexes do literal matches of strings, but sometimes you want to also match case differences. So a case is sometimes or sometimes called a letter case is the difference between uppercase or lowercase letters. So you have uppercase A, B, C, and then an example of lowercase a, b, c. So you can match both cases using what is called a flag. There are other flags, but here you'll focus on the flag that ignores case, which is the I flag. So you can use it by appending it to the regex. So appending is pretty much like just adding on to. It's another word for just saying I'm going to add onto this string or this object, this whatever element you're wanting. So you can use it by appending to the regex. An example of using this flag is ignore case and then putting an I at the end of it. See right there. This regex can match the strings ignore case, and ignore case, no matter how it's defined. So if you want a literal, like I want this case to match exactly the way it is, right? Then you would just put it in like this. You wouldn't put a flag on it or anything. But if you're saying, well, I need to find specifically this. So write a regex, FCC regex, which is right here. That's our value to match FreeCodeCamp, no matter its case. So we'll put, free code camp all lowercase, right? But in order to make sure we match it, we'll put an I at the end of that. So that way it's saying, I don't care what case it is. It can be uppercase, it can be lowercase, but we're going to find it. So that's what you would do. We'll run that, and it comes out to be, you know, this is what is going to come out to be true. So if we do a log, you know, result, right, it's going to come to true. See, I could just add a random C in there, and if I take it away, it comes to false because, you know, it doesn't exactly match anything in this string. So there you go. So you want to store the string in one, you store the regex and what you're wanting to find in another, and then finally you store all that, the results in, or the test results in another variable. Alright, so far you've only been checking if a pattern exists or not within the string. You can also extract the actual matches you found with the dot match method. To use the dot match method, apply the method on the string and pass it to the regex inside the parentheses. So instead of doing a test, you can actually store it within a string. Okay. So instead of storing yeah, you can store it into a variable, but I'm seeing a dot match for hello, so you can also extract the actual matches. Apply the method on a string and pass it to the regex inside the parentheses. Okay. So it takes the string and then it uses a dot match. So here the first match will return hello, right? Right. And it'll actually take it out and put it into an array, it looks like, and the second would return expressions. Okay. Note that the dot match syntax is the opposite of the test method you have been using thus far. So, in test it's true or false. But if you're doing a match, does that come out to true? But it'll return hello. So it doesn't actually give you a true or false, it just gives you the actual letter wording. I'm assuming. Might have to mess around with that. So if we have a string right here, match regex, right? If we use the regex.test and then put a string in here, which is this, this should be true. Or would it be false because you're taking it out? Huh. So let's try this. So change this line, change this line. So we want to take the word coding out of it, right? Right. Okay, so if we're using the coding regex dot match, is this what we would do? Dot match, function, okay. So how would, okay, so would we do the opposite? we put the string, and then we do a match. So the exact, okay, so dot match on the string with coding regex. So what is that? So console.log result. Okay. So it basically converts it into an array, giving the details of it. That the index is 18, input exact the word coding from the string, which is what the full input is, and then groups are undefined. So the result, so we have literally taken out this from inside here, and along with all of its properties or attributes, it looks like. So if it finds a match, it'll store that actual value into here, into result. So it comes out as coding. Okay. So what if I put an I there? Oh, wait. And a forward slash. And then we put like a capital D right here. So right here, it stores coding in that word, even though it says coding right here. So we want to match no matter what font, no matter what no matter what uppercase or lowercase it is. So yeah, there we go. All right. Like I said, at some point we'll probably might forget how to use this and probably have to go back and try to figure it out. And that's just, sometimes that's just how it is. But you know, trying to pick things out and pick it together. Hopefully I don't lose it. So let's try looking. So far, you have only been able to extract or search a pattern once. Okay. So if you have repeat here, match would return repeat because this is exactly what we're looking for. And then it takes repeat out, and then it adds it. You know, it takes our test string, matches to our regex, and so it returns the actual this in an array, the value into an array. To search or extract a pattern more than once, you can use the global search flag, which is a G. So it doesn't stop at 1. It'll keep going. Match returns the value repeat using the regex star regex. Okay. So we have to find twinkle words from the string twinkle star. So we need to so one, there's a G. So do we put an I in a G, or do we just do a G? Search and extract a pattern more than once. So we can do this. Okay. So you can have multiple flags on your regex like that. Okay, so that's what it wants us to do. So what we'll do is we'll search twinkle, because this is what we're looking for, is the twinkle word, but we also want an I and a G, because we want to ignore the font or the case, right? And then we have a G, which is like, okay, we might find one twinkle, but I want to find them all and store it into here. So in order to store it, remember, we have to extract it. So match, and then we'll put the regex in here, the star regex. There you go. And then we will do console.log to see what we have, results. So there we go. it creates an array, and these are our results inside here. So then when we add those, right, we have this. We can then, which is really cool, you can make a loop and then print them out into like a p tag into like your HTML or whatnot. Like if you make like a drop down menu, or if you're searching and it pulls one of those menus out, well, it'll actually list every single one that's in there. So that's why these are kind of important, because it's like, okay, we can find Twinkle, right, with I, but we don't want just one result. We want to find all of them. So you would put like an IG, so that way you find everything more than once, is what it's appearing to me. So let's go ahead and we'll run that. So we're good on there. Sometimes you won't or don't need to know the exact characters in your patterns. Think of all the words that match. Say a misspelled word would take a long time, right? Luckily, you can save time using the wild card character, which is a dot, okay? So the wildcard character will match any one character. The wildcard is also called dot or period. You can use the wildcard character just like any other character in the regex. For example, if you want to match hug, huh, hut, and hum, you can use the regex, the / HU, and then put a dot there for a wild character. So that wild character can be anything. And in some other programming languages, wildcards they could use are like percentage signs, or they can use like the asterisk, or like the star symbol, as some would call it. But yeah, this would be like a wild card. So this can mean anything, any string. So it matches numerous things. So complete the regex, unregex right here. And so we want to basically find everything that ends in un, right? So how will we do that? So we'll put that wild character card, because we have every single thing is the same, only the beginning letter is different. So we'll put a dot there and then put a UN, right? And so we'll test it. This should come out as true. So should use the test method. Okay, so we're not, your regex, unregex should match, run the string. Let's go on a run. Right. So it should all be true. Now I have to see if it's going to use the dot. Okay, so it's not actually storing it like the dot match, so we're not going to use that. But so now we can, well, you already know, but this right here will print out true because we're doing a test. So we have the unregex, which we're taking the regex and we're doing a test on it to see if it's in here. So remember, if we're doing a match, it's the opposite. We do a string, and then we do a match on the regex, the regex. Okay, so run test. You learned how to match literal patterns, right? In the wildcard character, those are the extremes of regular expressions, where one finds the exact matches and the other matches everything, right? There are options that are balanced between the two extremes. You can search for a literal pattern with some flexibility with the character classes. And character classes allow you to define a group of characters you wish to match by placing them inside a square, or inside square brackets, right? For example, you'll want to match bag, big, bug, right? You want to change the middle word, right? But not bog, right? You just want to change these three things, but even though this matches, you don't want to do that. So you can create the regex B and then have an AIU to specifically match that, and then it will return all of these matches, it looks like, with just those middle characters. So the AIU is the character class that only matches the characters A, I, or U. So in order to match, the for match calls would return the values big, bag, and bug, and null. Use a character class with the values A, E, I, O, U in the regex vowel regex, right? To find all the vowels in the string quote sample. Okay, so be sure to match both upper and lowercase values. Okay, so we've done that before. So let's go ahead and we have to find, what are we looking for? Use a character class with vowels A, E, I, or U in your regex. Okay, so we just A, E, I, O, U. Alright, so now we have to I for searching everything, to make sure we don't discriminate on upper or lowercase, and then we have the G for the global to return multiple. You should find all 25 vowels. Your regex should not match any consonants. Okay, so what do we have here? Oh, wait. We need to change this line, right? So, do we do a test? No, we want to take it out. So we would do the quote sample dot match and then print out all the values in here that it finds. So now console.log, it should return the E, A, E, U, or the A, E, O, U, I, etc. So let's see, result. Yep, see. So these are all the different ones that pulled out of there, right? So we'll run the test. So this is good, because if we want to be like, okay, I want to search and find all these values inside of a string, right? And then you could do a loop. So you could say, like, how many times does this occur inside of here? So you can run that, and then you can say, if, you know, this result comes out to true, like every time this comes out to true, add 1 to this like counter, and then, you know, at the very end you can return this counter. So it's a good thing kind of to know if you're wanting to like find a bunch of different values or different like different entries in data. So that's good. Alright, so off to the next. Match letters of the alphabet. So you saw how you can use character sets to specify a group of characters to match, but there's a lot of typing when you need to match a large amount of characters. So, for example, every letter in the alphabet, right? If you need to find stuff that is like, you know, all lowercase a through Z, or uppercase A through Z, you know, that's a lot that you'd have to type in manually, and, you know, there has to be a shorter way. Well, there is. So if you want to match every lowercase letter, let's say right here, A through E, instead of having to type every single one, you can just put in A through E. Or, you know, same thing. So as you can see right here, this line, it's going to find every letter A through E, and then anything that ends with at. So whatever it finds, it'll then put that into an array. So in order, the 3 match calls would return the values cat, bat, and null, right? And since there's no, you know, I or G, it's, you know, this case sensitive, and they only store 1 in each. So match all the letters in the string quote sample. Alright, be sure to match both uppercase and lowercase letters. So match all the letters in the string quote sample. So, so we want to match all the letters. So does it want? Be sure to match both uppercase and lowercase. Okay, so we would just do an A through E, right? And then we would do I, right? So that should find every single one. So that now, how we do this, remember, we'll do the string quote sample, and then we will do the match, and we will store it as an array inside result. So now, when we do a console.log, it should show every single letter, I believe, inside. So, hold on a second, let me think. Yeah, result. Had a brain fart. So, here it's saying null. Now, why would that be? Quote sample, right? Dot match. Now, we would also put a G, right? So why is this null? So you have the A through E. Ah, so that's why. You always got to remember, when you're doing these, you have to do the blocks. So there you go. So if you're doing A through E, so it wants us to do match all letters. So if we want to match them all letters, we do A through Z. So see, it puts every single character in its own space in the array. So how we did that, we used this to specifically grab this, right, and put it into array. Now if we put like something at the end of it, like at, it will find every single thing that ends in at, like bat, sat, rat, all those, and it'll put that into an array. And then we have the I, which doesn't discriminate against uppercase or lowercase, and even though it finds one match, it's going to keep on going. So for the G, for the global. So we are good here. Alright, so that is how you do the A through, or searching. So now basically this is just saying that you can make it not only limited to letters, but you can also do this with numbers as well. So for example, 0 through 5, it matches any number between 0 through 5, including the 0 through 5. So you don't have to, you know, do anything special to get those two. That's already included. So you also have, you can also possibly combine a range of letters and numbers in a single character set. So if this whole entire thing, you know, has Jenny 8, 6, 7, yada yada yada, you can actually match it with A through Z, and then you can do the 0 through 9 as well. So create a single regex, right, that matches a range of letters between H and S and a range of numbers between 2 and 6. Alright, so remember to include the appropriate ranges. So let's do this. So you have your forward slashes and you got your box brackets. Okay, so let's do the A through, oh, it wants us to do H through S, so find everything that's H through S, and it wants us to do 2 through 6, right? So how would that look, right? So, quote sample dot match, right? So how would that look? Console.log result. Alright, so see, it only found one, right? We want it to do more than that. So what we need to do is we need to have the I to match anything, and then we also want the G, right? So there you go. So we found the L. This is an L for blueberry. It found the L between H and S, so that was the first one, and so on and so forth. And it keeps adding them into here, right? So we just took all of those, everything in here, and we added it, right? So this is a big thing, and this is a thing you guys got to know. So whenever you're typing in passwords and it's saying like you need to have at least one uppercase, one lowercase, a letter, or one lowercase letter, one uppercase letter, a number, and a special character, this is what they're doing to test behind the scenes. And that's probably a big epiphany, like, wow, okay. But yeah, that's what it does. So basically, it does like a little program, like a little script that's looking and set a piece of code that's just like, okay, does it contain each one of these? And if not, print out this, and it'll return you to the screen. And then if you do end up doing it, then it'll let you continue if all the fields are complete. That's how you can make sure integrity of what you're entering into a field text. You secure. I should reword that. To ensure protection and integrity of what you're entering, want your users to enter into your code. This is kind of like the base level, or enter into your forms or any kind of data system. So this is one of those things to basically check and make sure that what you're entering is compliant. And I know people are going to come forward and say SQL injections, and other hacks to where you can enter bits of code inside these areas to basically screw up your whole system. Well, this is one of those things where you can check for integrity and reject custom syntax or lines from going in, or scripts from going inside your code, and basically kind of throw it away, throw it out. So I'm not saying this is the only thing that goes into there. I'm saying this is just partially for integrity reasons. So making sure your passwords are, very complex. So we've done this. We're going to go ahead, reach 30%. So far, you've created a set of characters that you want to match, but you could also create a set of characters that you do not want to match. These types of characters are called negated character sets. So to create a negated character set, you place a caret character, or kind of like an up arrow, after the opening bracket, and before the characters you do not want to match. So right here. So we want to match everything, but we don't want to match the A-E-I-O-U, right? So we are just going to take it out. Matches all characters that are not a vowel, right? Note that the characters like dot, exclamation point, left bracket, @ symbol, /, and white spaces are matched. The negated vowel character set only excludes the vowel characters, right? So create a single regex that matches all characters that are non-number. Okay, so let's do that. So we do everything that is not a number, so the 0 through 9, right? Not a vowel, so A, E, I, O, U. Okay, and then we want to include don't discriminate between uppercase or lowercase, and you want to find it multiple times. So now let's go ahead and match that. So quote example dot match. There you go. And now let's look at the return, or result. Sorry, not return. Okay, so we are a null on here. Why would that be? So let's look at our code, and once again, we found you have to make these literal matches. So everything that is outside of there, we are matching. Okay. Okay. So there we go. So remember, it's going to take out the 3 because that's in between 0 and 9. It's going to take the blind. It's going to take out the I in blind, the I in mice, and the E. So everything else, it's going to get the space right here, the space right here, and the period. So just be aware that it's going to take everything else in there other than those, just by adding the caret character. Okay, so let's run the test. We're good on that. Match characters that occur 1 or more times. So sometimes you need to match a character or group of characters that appears 1 or more times in a row. This means it occurs at least once and may be repeated. So you can use the plus character to check if that is the case. Remember, the character or pattern has to be present consecutively. That is, the character has to repeat one after the other. So for example, if you put A plus in there and G, so it's going to find anything lowercase a, would find one match ABC, right? Would find one match in ABC and return A. Because of the plus, it would only find a single match in AABC and return AA. It would also find a single match in AABC and return AA. If it were instead checking the string ABAB, it would find 2 matches and return AA. So basically, if there is multiple things happening, like multiple values, and you want it in one, you know, in the first like placeholder of like an array or whatnot, or in the same line, you can just add this and add a plus, and it will get everything that is after it as long as it's the same. If there's an A, and since there's a B right here, these two are not going to be in the same, they're going to be in separate. So if it'll be like A, and if there's 2 A's together, it'll put AA, etc. So because the A characters are not in a row, there's a B between them, there's no A in the string, B, C, D, it wouldn't find a match. You want to find matches where the letter S occurs 1 or more times in Mississippi. So we gotta find S, right? And then we put the plus, and then G, right? Where regex, they use the plus sign. We want to find matches where the S occurs 1 or more times in Mississippi. Alright, so this is already done for us, so let's look at the results. So console.log result. So there's 2 S's and there's 2 S's here because of the S's, and in Mississippi there's 2 S's next to each other, so it puts them both in the same right here. Now if you took out the S and then took out the S here, it would just put 1 S right here and 1 S right here. To one match or more S characters should match 2 items with 2 matches of SS. So this basically gets the number of matches in result. Okay. Alright. So we can find, okay. Now, if you need to find... Yeah, so basically that plus sign just lets you know that if there are more matches or not, it looks like. The last challenge, you use the plus sign to look for characters that occur 1 or more times. There's also an option that matches characters that occur 0 or more times. The character to do this is the asterisk. So now we have to remember that. Now this is the hard part. So you're gonna have an asterisk, and you're gonna mistakenly think this is a wild character, but it's not. Remember, the dot is the wild character, so you'll have to keep that in mind. In order the 3 match calls would return the values go, because it's matching Soccer World. It's matching everything with GO, and then it has the asterisk at the end, so 0 or more times. So this appears once. The GO appears one time. Appears one time. You got so okay, so G and O. So it's not looking for, you know, go specifically, it's using each individual character. So you have go on here because they both they're both together, so it all adds in one. But see, it found a G in gut feeling, but it didn't find an O, so it just finds a G. And the last one, it didn't find a G, but it found an O, but it still returns null because it doesn't match GO. So it has to have this to match this one right here. For this challenge, Chewy quote, okay, has been initialized as a string arg behind the scenes. So create a regex, Chewy regex, right, that uses the asterisk character to change an uppercase A character, match an uppercase A character, so A, right, immediately followed by 0 or more lowercase characters. So there. So it'll print A and everything that has capital A and everything that has A and lowercase a. But if it has only lowercase a and not this preceding, then it's gonna just report null. So it's gonna say, yes, there's a character A in here. Yes, there's an, you know, AA characters together. It'll have this, and it could have this separate, but it always has to have this. And if it doesn't, it reports null. So match Chewy regex. So console.log. And it wants to find, does not need flags or character classes, and it should not match any of the other quotes. Okay, so we're only just doing this once. So results. So it found, out of arg, it found the A's proceeding with the other A's. So run the test. There we go. So you can make like a custom code, like have the user saying, okay, I want to find this specific thing, or the first two letters, and, you know, see if it matches a result, and then you can even return that result to like a search engine, something like that. So we'll run the test. Okay. So in regular expressions, a greedy match finds the longest possible part of a string that fits the regex pattern and returns it as a match. The alternative is called a lazy match, which finds the smallest possible part of the string that satisfies the regex pattern. You can apply the regex T, and then you have an A through Z, and then you have the asterisk character after for anything preceding, and then an I. So the string you can apply the regex this to the string Titanic. This regex is basically a pattern that starts with T, ends with I, right? but everything in between. It has some letters in between. Regex expression by default greedy, so the match will return Titanic. So it find everything after, but it won't put the C because it's just finding that. And finds the largest substring possible to fit the pattern. Now, however, you can use the question mark character to change it to a lazy matching. So Titanic matched against the adjusted regex T, A through Z, and then anything preceding with a question mark. So it just returns the smallest thing, and it just returns tie, and that's it. It doesn't go all the way to Titanic. It goes just to tie, because this right here, it just finds, okay, here's T, here's I. Well, this is just optional right here, so we'll just grab T and I, and that is the least. So parsing HTML with regular expressions should be avoided. Yeah, but pattern matching an HTML string with regular expressions is completely fine. Okay. Yeah. So fix the regex to return the HTML tag H1 and not the text. H1 winner is coming H1. Remember, the wildcard in a regular expression matches any character. So let's go ahead. So we want to okay, so it wants us to use so we want it to match specifically H1, right? So we would do H1, right? But we also want to make it lazy. Oh. Well, no. It wants us to have an H1 right here, right? But if we put this here, right? The question mark. So let's find what results looks like. So console.log result. So as we see right here, it'll come out to H1 because we're putting the H1 here, but we're making it a lazy thing instead of the full text. So this makes H1. So should use lazy matching. Should not include the string. So we can't include the string H1. So okay. So H and 1. No, 1, right? And then that, and then it uses a lazy indicator. I mean, it does, but should not include the string H1. So we can't put it in there, so we have to do a, or is A through Z, right? And 0 through 9. So there we go. So we do an A through Z, 0 through 9. That is in this one. That is inside this bracket and this bracket. So the input is winner is coming, and it does H1. Alright, so, and it uses lazy. So there we go. So it finds an H in this that has a, in here it finds, okay, here's this. And then A through Z, it finds an H. And then right here, it finds a 1. And then it has this. So instead of finding anything that comes after this, it says, screw it, I have these two right here, or I have what I need right here, and I'm able to get this. I'm getting the first thing I see that's short, and this is the first thing it grabs. So, there we go. Alright. So, we've reached about an hour so far. So I hope you guys are still following along, still hanging in there. I've had to, as you can tell, adjust my legs a few times, because truthfully, it's kind of cold. Whew. But yeah, alright, so now we are on our own, it looks like, for this one. Maybe. Time to pause and test your new Regex writing skills. A group of criminals escaped from jail and ran away, but you don't know how many. However, you do know that they stay close together when they are around other people. You're responsible for finding all the criminals at once. Here's an example to how to do this. The Regex Z plus, yep, matches the letter Z. When it appears one or more times in a row, it'll find matches in all of the following strings. But it does not find matches in the following strings since there are no letter Z characters, right? Right, a greedy regex that finds one or more criminals with a group of other people. A criminal is represented by the capital letter C. Okay, so we're gonna change this. And we're not going to know what we're having, so we want to change this by doing the capital letter C with a plus, right? But we also, because there's no Z's, right? So, yeah. I was going to say, because they'll just find anything with a C that's only a capital letter, and then find anything with capital CC, or it'll return one C. Now, if we put an I here, then that would be, like, it'll match C and then a lowercase c, right? Or anything matching it. So that wouldn't be correct. And if we put a G there, then it's going throughout and it's adding multiple things. So, can we put a G there? And we can, yeah. So if we put a G there, that means we can find multiple that are all returning that match exactly this case. So it is case sensitive right now. Okay. Pretty easy. Nothing too big. Ooh. All right. So, prior challenges showed that regular expressions can be used to look for a number of matches. They are also used to match for patterns in specific positions in strings by an index, right? In an earlier challenge, you used the caret character inside a character to create a negated character set in the form, yeah, things will not be matched. Outside the character set, the caret is used to search for patterns at the beginning of strings, right? The first test we'll call true. First string, or testing that. First test would call return true, while the second return false. Wait. So the not, it's supposed to exclude that. Wait. To create a negated character set in the form. Outside of a character set, the caret is used to search for patterns at the beginning of string. Oh, okay. I get it. So basically it's saying that, okay, this right here means that Ricky is at the beginning of the string. this return true. Now, if you tried to do this, Ricky, is right here, right? If it's not at the beginning, it returns false. Now, remember, the reason why this is because it's not in the box. It's not in the box brackets or in the brackets. So outside that brackets, it represents the beginning. So we want to find cal and make sure it's at the beginning of the string. So we put a caret and then cal, right? And then that will return true because cal is at the beginning. So result, or no, console.log result, and that should report true because it is. If this was like right over here where cal, if we put cal right here, right, and say, okay, we're taking out this right here, it'll return false because it's no longer at the beginning. So that's what it's doing. So it has multiple meanings, and depending on how you use it is how it will match. So in the last challenge, you learned how to use the character to search for patterns at the beginning of strings. There's also a way to search at the end of strings, which would be the dollar symbol or the cash symbol. You can search the end of string using the dollar sign character. So at the end of the regex, so the first test would call return true, right? Because story's at the end, and this would return false because it's not at the end. So basically same concept, just different. Instead of at the beginning, it's finding it at the end. So we're gonna find caboose, which is an interesting word, and then we're gonna put the that money symbol at the end to check and make sure it is at the end. So we will do the console.log result and see it's true because caboose is at the end. All right, halfway done. Almost done. Through regex. So thank you guys for halfway, like, sticking through it this far. Doing pretty good. And hopefully you guys are learning a lot of comparisons. So using the character classes, you are able to search for all letters of the alphabet with A through Z. This kind of character class is common enough that there is a shortcut for it, although it includes a few extra characters as well. So the closest character class in JavaScript to match the alphabet is \W. This short is equal to A through Z, capital, A through Z, lowercase, 0 through 9, and underscore. This character matches, class matches upper and lowercase letters plus numbers. Note this character class also includes the underscore character, so it has all of these plus the underscore character. Okay, so all four of these tests call will return true. Yep, because in here there will be A through Z's and A through Z, all this, that will return true. And then we have the \W, which takes all of these right here and then has the plus. So any one of these proceeding with, one or more of the characters in a row, number 42 is equal to 42. So these are our tests right here. This is just a shorthand and longhand. So we just do the test on numbers, right, for longhand, right, on numbers, and then you do the shorthand numbers, that returns true. You do the variable names, returns true, this returns true. So it all returns true. So in here, right, to count the number of alphabet characters in various quotes and strings. So instead of having to do I, put the I character, you can just do this and W, right? And then to count the number of alphabet characters in various quotes and strings. So we want to count it. So we put a G at the end, right? So let's do, okay. The length. So result, result. So let's look at this. So this is equal to 1. And then if we put a plus there, it'll find everything after. Okay. So it found 31 matches. So for each one of these, it just gets all of this, right? It just takes all of these and puts it in there, right? But if we add a plus, where there's a W and where this occurs and there's more, like it goes with WW, or not W, but if it has two of the same, so where would it find 6? Oh, okay, so it just finds matches, like you have individual. So what if we took out the length real quick? So the, right, 5, right, boxing, wizards, jump quickly. So it takes all of these, right, without having to do the spaces or the period. So this, it just takes each one of these. So it takes the first letter and then it takes the rest. And because it's wild characters, or since it's all of these right here, it's going to find this W and then it's going to get everything until it reaches something it doesn't recognize. Whereas if we do, you know, this, it's going to get every single one of these and put it in there. So that's why we add the plus here, so that way it gets everything until it hits a space or whatnot. So there you go. Alright. You're ready to find 31 alphabetical characters in this. Right, 32. So what it wants us to do is, it doesn't want us to have the plus. It wants us to have all of these. Now we have to put it all in a length to store the number. So it finds 31. So there we go. So it finds all of them. If I took away the G, it only finds 1. So it's the T that will be put in here, because it finds the T and says, okay, we're done. See, index is at 0. So we'll do that. We'll put the G there so we have all of them in there. So we have 31 matches. Okay. So this is how we could like we can have a user type in an input, right? And then we could add the plus symbol to that. And then we could find, you know, we can add the G. Or I and G, so that way it returns kind of everything that that matches that specific line. But there are a lot more ways to get, like, you know, full items. So you've learned that you can use a shortcut to match right here using \W. A natural pattern you might want to search for is the opposite of numerics, alphanumerics. So you can search for the opposite of \W with \W. The opposite pattern uses capital letter. This shortcut is the same as not finding A through Z, all lowercase, A through Z numbers, you know, and underscore. So it's going to look for the percent. It's going to look for, you know, the exclamation point, because that doesn't match any of those. So the first match we return the percent, which is right here. Second match we return this, like we were talking about. So this is how you find the you want to find everything that doesn't match these, right? Like illegal characters or something like that. So if someone tries to type in like any of the any character that's outside of this right here, then you could be like, okay, they're trying to put like left angle brackets, they're trying to put all this kind of stuff in there, they're trying to do, you know, statements, and that sort of stuff. We can't have that. So that would be a one way, is if it detects like an exclamation point or something that is not inside those limits. So you can add the, you know, the \W, and then you can insert manually your own, like, you know, symbols, like the exclamation point, the percent, that sort of stuff, and then everything else will return. So you can make omissions to make sure, like, if you want to create passwords and that sort of stuff with these special characters, you can, but you can't use the left angle bracket, you can't use the right angle bracket, you can't use these specific ones. So that's how you can define those specifics. So this is exactly what's used for password protection. So when we create our passwords, we do a test, and it's like, hey, is this actually, you know, is this good? And then, you know, it checks the program, and if it catches something, it'll show you. It'll display an error, but if it does, it'll go to the next page, or it'll say, you know, password created, something like that. So use the shorthand character with the capital W to count the number of non-alphabetical characters in various quotes. So we'll put the capital W to find all that, and we'll put G to match all of them. So how many are we going to find? So console.log result, we're going to find 6. So there is 6 of these. So 1, 2, 3, 4, 5, 6. And that should be true. Yep. So naturally, if you're learning this by yourself, this might trip you up a bit. Like, I know whenever I did this by myself, like trying to understand, you know, regex, it was a nightmare. It was sitting there going, you know, what does this mean? Like, you know, what was that thing again? Like, how do you search? Like, whenever I was looking in the inspector and I was looking at things, I would see, you know, like these kind of things where there would be like a caret and then the A through Z and uppercase, lowercase, that, and I'd be like, what does that even mean? And even sometimes in college we'd come across those kind of stuff, and, you know, we didn't really go over that much when I was getting my degrees, which is, it's kind of weird. And it also depends on where you're going to, and I understand that, but that's why college is a lot of fundamental learning and that sort of stuff. And then once you actually start getting out, you start learning a lot more material. So this is kind of one of those things that are just like, you know, specific matches, here's how we're going to do this, and, you know, making sure we're using, you know, authentication to and reliability, and like just basically catching stuff that's not supposed to be there. So let's go ahead and keep going. So you've learned shortcuts for common string patterns like alphanumerics. Another common pattern is looking for just digits or numbers. So the shortcut for looking for this for digit characters is, \d with a lowercase d. This is equal to the character class 0 through 9. So if you're like, okay, I want to find these, I don't want anything else, that's how you do it. So we do the \lowercase d, g, and now store 2001 in here with just the \d in this. So \w is, searching for all of that, all of those specs, all those uppercase, lowercase, numeric, alphanumeric values. And then the capital W is finding everything that is not alphanumeric, or finding those symbols and like spaces and that sort of stuff. And then you have D, which is, \D, which is just looking for, digits, numbers. It's just looking for numbers 0 through 9. So there you go. And then if you put, the plus right here, it's going to find 1, which is, 2001 for 2001. And the length should be 1, so console.log result. It should be 1. Yeah. And then when we actually look at this, when we take away the length, it should be 2001. Because we're getting the 2 and it gets everything after that until it reaches a symbol or a space that doesn't, or at least anything that doesn't match a numeric. So that's what it does. So we'll do the length again. Now if we take out, obviously, the plus, it just gets, it puts it into every individual value and says, okay, there are 4 occurrences. So, yeah. So now we need to get the length, dot length. So to make sure we get the number, and yeah. So there we go. Okay, at 60%. Not too bad. It seems like we're moving pretty good here. The last challenge showed how to search for digits, okay, with a lowercase d. You can also search for non-digits. So everything that is non, so like we did with the W, we're going to capitalize the D instead. So it's basically the same as omitting, like putting the caret and then the 0 through 9, right? So we'll do \uppercase D, and we're gonna find multiple and then find the length, right? How many non-digits are in movie titles? So let's go result, console.log to check our work, result. So the reason why we keep doing this console.log with results is we're debugging, like we are, testing. We're trying to make sure that, gosh darn it, that, everything that we're putting in is coming out the way we're intending. So there you go. Non, so everything other than this. So this counts as 1, this counts as another one. Oh, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So does it not count this? So let's see what it's actually counting. So it does include this, right? This right here. So 1, right? The space, 2, 3, 4. Oh wait, that wasn't 16, it was 17, right? That's why it was 17. I thought it was 16. So yes, there is. It's 1, 2, 3, 4, 5, 6, 7, all the way to 17. So we're getting everything that's not digits. Okay. So this is also one of those things where it's like you can test for individual things like actively. So when instead of prompting you for those alerts, right, it'll actually show those little things on the side, those little, little bits of like text, like on the website, like when you're creating your password, it'll be an X, 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 X. But if you do it correctly, it'll have like a check mark next to them. And that is what these are. So it's just individual checks. And then if this matches this, it'll make, you know, this happen. If this matches this, this will happen, and so on and so forth. So that's how you can tell, like, actively, if you're missing something, it'll tell you what you're missing. Or if, you know, something's not aligning. So we'll go ahead and run this test right here. And that should be good. Alright, so now we're going to restrict possible usernames. So usernames are everywhere on the internet. They are what users give a unique identity. So here we go. This is the first part. When we create a username on the site, we want to make sure that they are matching they are matching what they're supposed to match. So need to check all the usernames in the database. Here are the simple rules that users have to follow when creating their username. So usernames can only use alphanumeric characters. So we're going to check in here. We can change and see that if they're using it. So they have to use... so we're checking... Let's check this. So we're going to take this out, right? We're going to take this. So the first thing is... Let's do this first. First thing is we want to check and make sure they're using alphanumeric characters. So \W, there you go, right here. But we might not want the underscore. But it doesn't say that we can't use underscores. So the next thing is username cannot start with a number. So remember at the beginning, we have to make sure that 0 through 9. So we instead of 0 through 9, we just do a \, with a D, right? So this basically says, okay, we're not going to start with a number. We have to have, you know, we have to use alphanumeric right here. Username letters can be lowercase and uppercase. So that would be a \W, right? Usernames have to be at least 2 characters long. So can only use alphabet letters as characters. So so we can't have... Alright, so hold on. Only numbers in the username have to be at the end. So we'll have to do this. Backtick D, right? And we have to put the S symbol at the end because it has to end with T. So the only numbers in the username have to be at the end. So let's do A through capital Z and then lowercase a through Z, right? So we can't have any numbers through here and only numbers at the end. Alright, so characters have to be 2 characters long. So right here, will we put a plus symbol in that, in here? Or no, it'd be a plus symbol right here. Because we want to have more than 2. Right? Okay. So I think this is right, but I might not be right. But we have the A through Z, which is capital. We have the lowercase, right? We have the plus to ensure that it's more than 2. And \D ensures that we have a digit at the end with the money sign. So we can test it and see where we're at. So result. So what is it? What is our result right now to test? So console.log. So result. So right now it's false. So this is an if, right? So we would put this at the end. Should master string jack, right? So can we put G? Okay. So it has to through Z, right? Here we do the plus inside here. And then it has to end, right, with the backslash D, right, with the here, right? So we have an A through Z. So this is true. So uppercase A through Z, it's searching to make sure we have a digit at the end, right? Oh, oops. And then we don't even need that, I don't believe. But we should still have a plus in there to make sure we get all of it. Oh, sorry about that. Okay. So, and we have to have a plus. So that way it finds it. So your regex should not match the string J. Wait, this is here. Should not match the string 007. So this is. So we're taking the username to test this, and this is true. So it should not match any of these. Right? So we don't want okay, hold on. Okay, we need to check this out. So we have all this. This is right. Now, should not match the string J. So it needs to be more than this. And it needs to be longer. So do we put the I here or the plus at the end so it finds more? Or do we put the it needs to have another. Do we put a dot here then for a wild? Okay, so okay, this is true because it's working, but like this isn't true though, because finds A through Z. And then this has to be at the end, right? So we can do this. Yikes. So it finds it at the end. So if I change that, what was the difference if I ran the test? What were we all? So we do need to. Oh, wait. So. Will we do uppercase? Oh no, because that'll look through all of it, right? So this will return 007, that it can't match the string. So it's making sure that the string is at the end, right? Ocean's 11 should match the string Ocean's 11. Okay, so we can do a D, right? Right there. But it has to be at the end. Should match the string jack. Oh man. So what would that do? So it does match 11. It doesn't match the string 007. Do we omit with not having a numeric characters? So we put this with a capital D right there at the beginning to make sure it's not the beginning, right? And we want to make sure because we want to do A through Z. So what was the Ocean's 11, right? Should match the string Z97. So it can't start here. If we do, so would I do like a \W, right? And then add a plus to make it there, but this has the end right here with a letter, and it can't start with a or. Okay, so we're getting kind of there. We're using this right here to match jack of all trades. Cannot start. The letter at the beginning cannot start with the D, so this is correct. And then we have the W plus, so it should go with all the way here. So let's this is a test. So let's do a let test equals user, let's do the user, wait, yeah, username, username dot match, with user check. So let's test the test and see what it produces. Produces a null. So it can't start with a number. So, okay. But it should have the jack of all trades. So it should do the capital. It should not start with this. which it should not start with the 0 through 1 or anything like that, so that's the good. But it should have matching here. It should have capital. So what if we put Ocean's 11? But it's okay, so it came out as null. Okay. Still coming out as null. Username dot match user check. Should match the string Jack. So we have this, that at the beginning it should not, there should be a non-decimal at the beginning. Right. So it should have, well, a non-number at the beginning. So could I just do the same? No. Right. So if I did this, it has to have a letter like a through Z, right? And an A through Z. So it should have this at the beginning, right? And then so it should have a non. What would this get? Okay, that kind of screws us up. It should have Jack beginning. So so what if we did W, right? Okay. Should match the string Jack. Ooh, man, this is the part where it's getting hard. Okay, so let's start this. We don't want the D in the middle or at the beginning. Like, we don't want any numbers at the beginning, 0 through 9, yada yada. We don't. We want these A through Z through Z, right? And lowercase a through Z. But we would omit the 0 through 9. But that wouldn't make sense because we can't, because then it won't allow any numbers 0 through 9 in it. So it only wants A through Z, don't have it at the beginning, and have a number at the end. And okay, so it should match the string Z97. So would it be 0 through 9? Okay. Should not match the string. So what? The number characters in the username have to be at the end. not start with a number. So these have to be at the end. So can I put this? Oh. So can I do that? And then can I add another one with, so it has to have this, but 0 through 9 at the end. Jeez. Okay. So if I do the 0 through 9 here, so this will just match all of these because I can't. So what's happening here is test match. So it's matching 007. Why is it returning null to everything? So I have the username dot match the user check, which is here. What is an if? Because this is basically saying that it has to have this at the end, but oh, what's Regex Guru? So I doesn't matter. Well, it's basically the same thing as W. So let's see what we have here if we just get rid of this, right? So we have Jack. It doesn't start with a number. We have the W and this. And so the output is JA for Jack. So this is Jack of trades. It's matching the JA. And if I put a J, it's still doing the JA. Nope. 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 Has to start with nothing. Has to have another letter. Should not match the string A1. Alright, so should not match the string A1, but it matches A1. So wait, that's at the end though. So it's matching all of these. Should not match the string username. So since there's a So can I omit the A through, so it has to have another right while character here. A through Z, A through, or A through Z, and it has to omit 0 through 9. Should not match string, should not match. Because it's in here, it has to be at the end. No. It's false. Because there is none here. It starts with there. So it should not match, but it is. So if I take that out. Okay, so it's doing the same thing. What, the asterisk, that, oh man, what is the asterisk? Now I'm trying to think, what does, so it did match Jack of Trades, right? Because it's just following there. What is, oh man, someone's gotta have to remind me. What was that asterisk? Because now I'm drawing a blank. The asterisk was, it's not a wild symbol. Yep, see? Zero or more operator. Just string me up to 0. Zero or more occurrences in. So, okay. Okay. So J slash D the end. I had the plus. No. Okay. So we had this. Should not match the string H A1. But it does, because that starts with an A1. So it has to be So 2 has to be 2 characters. How many? At least 2 characters long. A 2-letter username can only use alphabet Okay. If it's 2, oh my god. How do I check? Like, if it's 2, it uses that much. Now I'm just drawing blanks. Now I need to figure this out. This is 2 wild characters. That's to go through A through Z. Alright. So it has to have at least 2. Has A through Z. And or okay, so I can put the or in here. Operator. So it has to match this, or it has to be a backslash W ending with a D at the end. Gosh dang it. Okay, hold on. Hold on. Can I do... Hold on. At the end. Oh, gosh darn it. Oh. So... it has to be 2. Okay, hold on. So we have this. It has this. Oh, could we do the or right here? Or we can take this, right? Copy it, put this here, and then add the D. Add this at the end. Right? Oh man. So D here, D at the end. No. 0 through 9. Omit that. No. 0 through 9. Crap. Do I put this at the beginning? For no 0 through 9. Okay. And then we get the rest of it. jack of all trades, right? And then plus okay, we're getting close. This is extremely complicated. Should not match the string bad username. Like as saying true. So are we looking for all the things it doesn't have? No. It is. It's finding all the things that should match. That are okay. Can I put this at the... Can I put the X right here? So wait a minute, hold on. Let's do this. So it doesn't start with that. We can do a 0 through 9 here. But it has to be at the end. But that's the same as doing this, right? A through Z. So what is Z97? So should do or should be this, or should not have it. It should have this through Z plus, and then have a the end. No, can't do that. Why doesn't that work? So it should have this, and two of these, two wild characters. Or put in this, and then just put Z. Z with D at the end. Oh, that doesn't work in here. Or A through Z. What is A plus? What is there an optional thing for a number to be at the end? I'm just having so difficult like trying to navigate through this. So you have an A through Z, which is capital, lowercase a through Z right here, right? But then you also have a while character. Wait a minute. So, occurrence, could I just do that? This is... this is making several things. So this is right, it looks like. Should not max string Joe. So let's look at this. All right. Opting out 0 through 9. Okay. So, can't have this in the middle because of this, but it has to end. So, okay. Can't start with that. So this is... So do we do this? What, do we add 2 of them? No. So we're so very close. So this is null, Jack of Trades. So well, this is the same thing as uppercase, lowercase. So it should match a string with nothing at the beginning. A through Z. A through Z, right? But, okay. How do... I forgot how to make that optional. How do I make that optional? I need to remember, is there an optional... Oh my gosh. Someone has to... I could use... Okay, how... Optional. And... let's see if we can find something in here. Yeah. How do we make it at the end? So that would be the short hand. So we have an A through Z, right? We can... So could we do it all different? So A through Z, right? A through Z, but then have a or 0 through 9. Okay, so we can do plus. Right. 0 through 9 plus. Right. So 0 through 9, and then have to add that, right? Son of a gun. So can I do... I don't think I've done qualifiers or anything like that. Let's put this back where it was. So your string should match the string Joe. So there shouldn't be anything at the end. What's an optional operator? So is this short? No, because then that would be so a while character. Right. So optional character. No, that wouldn't work. We don't need this, right? Occurrences, no. So can we find the shortest? No, because then it won't match that. But we just need to find... Could we... D... Would it have to be that? But this isn't optional. That would find the shortest, right? Oh, it wouldn't match that one. So we could do the plus. Because we omitted the zero here, but could we do D S? Okay, so so we have this. We have to have the uppercase, lowercase. Could I just do this? 9. Yeah, we can't have that either. It has to be A through Z, A through Z. But we're having trouble. I'm gonna have to look at some of the help before we keep going on. So let's see what's going on here. So all it gives us is solution. So for this one, let's see how they're doing this. So at the beginning, there has to be an A through Z, lowercase. So wait a minute. So the first has to be a letter A through Z, right? What's the other solution? Oh, okay, we haven't even done. So the first is the two characters. It has to be a letter and then another letter followed by more letters with the oh, okay, so we didn't have to do the A through Z. So we find this lower, and then we find the letter characters to get more letters following, and then there has to be ends with 0 or more digits, right? Or it starts with Z, ends with a digit, or so you did D, which is 1, and then you did another D, which is more. So 2 or more characters. And ends. And this is the end of input. And then I, so it's uppercase or lowercase, so we don't even have to do this. Add. So let's try that in practice. So let's try this again. So let's terminate this. So we're gonna keep this then. So at the beginning we want a letter A through Z. So that's what it's saying, right? Now we also want A through Z plus. So at the beginning we want this. Right here we want a letter with the preceding following letters. And then we want a digit at the end. Right? Or, so we do have the or we have one that starts at the beginning, A through Z. We do another A through Z plus A through Z, and then we do another A through Z plus, and then D / D plus the end, and then put an I at the end to make sure it's uppercase or lowercase. Okay, so we want to end with that. So to do this, to end with a D, 2 or more digits, and the I. Okay, so this is... Did I do the... I could have sworn I just did this. Or there's 2 digits. I need to... Gosh darn it, I don't want to keep... Okay, but I'm trying to figure out what am I doing this? Yeah. Oh. This right here. So we have at least 2. So it gets 1 at the beginning, it gets another at the end right here. So this is just if it's 2 digits, it needs to be a letter plus a D if it's at the end. Oh. So you have this right here, A through Z, and then you have your digit and then additional digits. So there's nothing in the middle or anything, it's just all letters followed by a digit and then more digits if there is at the end. So this is 2 plus digit if there's a digit at the end, so A1. And then this finds more 0 or reoccurrences. Okay. Oh. So this right here plus this. So we put this right here. So it gets all of these plus this. It finds reoccurrences and then the end. And then this just gets A through Z, a digit, and then following digits after. So this is making sure that all letters preceding are all letters A through Z, and then it's ending in a digit. And then this one has here A through Z, and then a digit, which is weird to me because it says that and the username have to be at the end. There can be 0 or more at the end. Username cannot start with the number. 2 characters long. A 2-character username can only use alphabet letters as characters. So the fact that it has this at the end on both of these is it's just different because this one doesn't have a D at the end. So jack of all trades, that comes out. True. So it's fine here. Okay, so this one's basically saying that it has to, that this is 2, if there's 2, it has to have a letter and a letter. But if it's more, right, it would have to have it, a number at the end. Now, in the second case, it's saying, like, you can have this when it's 1, and you have a digit, but then if there's another digit, it has to be at the end. So there has to be at least 2 digits at the end, and this has 2 letters right here. Because the letter right here and then the letter preceding it, and if that's the case, then it's happening. And then this means 0. Okay, so this makes a big difference because that asterisk means a 0. So if it's got nothing, it could just be these 2, and it doesn't have. It could have nothing, or it can have more. Either way, it has to have this. So here, it's just basically saying at the end there has to be a number, and or if there is, you know, a letter at the beginning, there's a digit, and then there's digits preceding. It has to be at the end, and then these can be uppercase or lowercase. That was ridiculously challenging, and it should not have been that hard, but oh my god. So the challenges so far have been covered matching letters of the alphabet and numbers. You can also match the white space of spaces. Okay. So you can search for white space using the \s, which is lowercase s. This pattern not only matches white spaces, but also carriage returns, so tab, form, feed, new line characters. So you can think of it as similar to the character class. So \r, \t, \f, n, v, yeah. So, okay, so let white space, so white space, white space, white space, so it takes these 3, or these 2 right here, and it puts the G, so it gets 2 of them right here and here, and puts it in here, and there's, you know, if you do a dot length, it matches 2. So, change the count white space. Okay, so S for the white space, G, so it finds it all, and so it's going to store all of those in here. So you can do a dot count, and it shows how many. Go to the next one. While searching for white space using the \s with the lowercase s, you can also search for everything except white space, which is so you can think of it being similar to the character class, where you have a caret and then you use whichever here. But searching here, So \s. Okay. And then G. Finding all that. So it's finding all the values that aren't here. So it'll do this, 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 this. Oh. Man. But we're not doing the plus, so it's not going to add, you know, all of these. It's just going to put every single one in the array. So 32. So yeah, we did that. So if we put .length, it'll actually give us the length of it. Alright. So recall that you use the plus sign to look for more than one characters and the asterisk to look for 0 or more characters. So that is where I got confused. Where 0 is looking for characters, and you know, we probably could have figured it out in some other way than what we did beforehand. And I thought we were literally on the right track. Actually, let us... I know, I want to try this one more. I just want to see if adding the omit would be okay, because I feel like I was so on the right track on this. But plus, and then this /d, right? But we had this. Okay, so either way. Oh. So what did we do beforehand? Okay. I just wanted to... Okay, so that's where we got hung up. Was in here. Because we didn't want... A through Z, A through Z. Is this when we added these two? Where we had... I could have swore we got rid of these. Okay. I don't want to spend more time on this, but I feel like... we were doing pretty good. I just wish I could have. So yes. So we have the Z plus right. And then if we put a D there, but you can see it though. Like the method that we were doing it, like if we would have kept going this way, we could have had that. So where we had the or, we could have done this. Where we had this, we had one of these characters, then we had a D. So this is where we would have the A through Z. Because we have to put that there. Okay. So this is what we would have had to do, which is pretty much hold on. Let this be. Same thing. We're just using this, the capital D, A through Z, plus. So it gets all, starts with 1, it gets the whole letter, like, following, and then it has a D, a 0, or extending to the end, and if not, we have one starting at the beginning, with a number, okay, with a number and then a number at the end if there's more. So we kind of were on the right track. So alright, so we're gonna do the backspace S. We've already done this for spaces. Oh, we already did this. Oh, G. Okay, let's just run through these real quick. S, get the non-spaces, G. Okay, so recall that you can use the plus sign to look for more characters. Yeah, Ash looked for 0 more characters. These are convenient, but sometimes you want to match a certain range of patterns. You can specify the lower and upper number of patterns with quantity specifiers. Quantity specifiers are used with curly brackets. Okay. And you put 2 numbers between the curly brackets for the lower and upper number of patterns. For example, to match only the letter A appearing between 3 and 5 times in the string AH, your regex would be A 3 to 5 times and H. So, okay. So the first test will return true because it goes, it found 3 A's, right, and an H. Or right here. So this is 4, 1, 2, 3, 4, and then it has an H. Now, it has 2 right here and not 3, so that made it false. So change the O regex. So we're gonna look for phrase "oh no" only when it has 3 to 6 letter H's. So H. So 3 to 6. Okay. Oh, match a string. Test. Okay, so okay, so O, and then 3 6 inches. I'll put an I there. So should match 3 to 6, right? Jeez. So 1 2 3, that would be log result true. Yeah, because it has 3 there. But what is 4? Okay, so this is A. Change the O regex to match the entire phrase "oh no." Okay, so we have right. A 3 to 5 times, and then H. So I have H, which has O. 3 to 6. And then a space, right? With the S for a space. You gotta be kidding me. Oh my god. So okay, so if I put an H here for 3 to 6, oh my gosh. Oh my god. Okay, so true, true, true. Why is that true? It only should have 3 to 6. Okay. 1, 2, 3. All right. Okay. So 3. So we have 3 now, and that matches. So 4, 5, 6, 7. So that's not how that's supposed to go. Am I how is this still true? I mean, it doesn't match this. A appearing between 3 to 5 times in the string AH for your regex would be A between H. So 1, 2, 3. Right, that's false. So we have 3. Okay. 4, 5, 6, 7, and it's not working. Why? Are you serious? Are you Tell me, what in the heck am I having an issue with here? I must not be getting it, because test. Oh, I should have between space, right? Between a space or right. Should I this? Oh man. So 3 through 6, I gotta run this. This is true, right? And if I just, there's 4, HH, HH. No, that's not how that's supposed to work. No, that's not even supposed to be a wild character. How? Okay. So H. 3 through 6 times. 3 through 6 times, right? Why does this work? Why is this H? This. Right. So only H. 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 it's there is no boundary. It's not. So let's put n. Huh? Between h and n. Sn, right? What's in space and then an n, right? So 1, 2. This is true. This is false. Okay, so 3, 4, 5, 6, 7. This is crap. It's just detecting that there's thing. It's not making a range, and I don't know why. I need a hint. What? I know, like, this is crap, but like, I did this. I did this. What? You guys saw me do this. This right here. And it was not doing that. Only when it has 3 to 6 letter H's. Right. So I did this. Dot test O string. Right? It's testing if it's true or false. If there's 3 to 6. Which is getting the lower, but it's not even detecting the higher. So 1, 2, 3. So there we go. It's less than 3, but we're doing H. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's just not. It's not working. So I need to figure out why that's not SF. Yeah. Oh gosh. Wait a minute. I have to put. I did the H after H, right? And then, yeah, I even put that expression. So either way, what I'm looking at is, so even though I had the H here, and I also like had the S for the space when it gets there, right? It still was returning true. So if I do O instead, but, and make sure we're looking for capitals. So 1, 2, 3, 4, 5, 6, 7. Okay, so I had to actually put O in that, or capital O. What a sham. But that's. Oh. Okay, wait. What? I had O. Space. How do you like that? It's not working. It's always gonna hit false now. So, because we have the I. So O. 3, so right. 2, right? So 1, 2, 3, 4, 5, 6, 7. False. This is because I have this. Oh boy. This O. And then there's an S. Could I just get rid of this? You see how this is royally screwing with me, right? For the space, then we can even put in a no. And an I. So it matches this with the space and then a no character. So this, does the space not even count as like a character? It's just until it hits this no. I guess so. And then if we match it exactly, it does this too. So I guess remember that backslash S does not always equal a character. All right. Specify only the lower number of matches. All right. The lower number or an upper number of patterns. Koi braces. Sometimes you only want to specify the lower number. So you basically just don't include the second one right here. So you want to get match the regex huzzah only when it has 4 or more Z's. So H-A-Z, and now we want 4 or more AH for huzzah, right? There we go. And then you can also make it an I, so that way no matter what these are, it'll match. So there we go. And we can have the highest match only the word with the letter A 3 times. So you want to match it as specific. Number patterns just have one number between the curly brackets. So if you want to make sure that this has like timber, so Tim, you want this match the regex to match the word timber only when it has 4 letter M's. So 4 burr. So this is only going to match if this has 4. If it has less, it has more, it won't match. So this is explicit. Okay. And now, sometimes the patterns you want to match or search for may have parts to it that may or may not exist. However, it may be important to check for them nonetheless. So, you can specify the possible existence of an element with a question mark. This checks for 0 or one of the preceding elements. You can think of this symbol as saying the previous element is optional. Differences in American and for example, there are slight differences in American and British English, and you can use the question mark to match both spellings. So both tests will be written true. So in American color, you can use so this basically will match even if it doesn't have a U or it does have a U, to make it match both cases. So, and I sometimes get this mixed up. So we have here where we'll have favorite, but in British it goes FAVOURITE. So we're gonna put a question mark there to make sure the U, if the U is there or not. So that way it could test true regardless if you have the U or not there. Okay. Positive, negative, look ahead. Look aheads are patterns that tell JavaScript to look ahead in your string to check for patterns further along. This can be useful when you want to search for multiple patterns over the same string. There are two kinds of look aheads. There's a positive and a negative. A positive look ahead will look to make sure the elements in the search pattern is there, but won't actually match it. A positive look ahead is used as a question mark equals, where ... is the required part that is not matched. On the other hand, negative would be a question mark with an exclamation point, where the 3 dots in the parent that you do not want to be there. The rest of the pattern is returned if the negative look ahead part is not present. Bit confusing, but some examples will help. So quit has QU and no quit has QT. So regex Q will look to see if there's a U, and then regex QU regex will use the question mark to find a U to see if there's a QU, and then if they're in here, if there's no QU, it'll return false. Well, both of these match calls would return Q. So, return Q. Okay, so it has Q, but it's checking to see if there is one in there. Because it's to check 2 or more patterns in one string. Here's a relatively simple password checker that looks between 3 and 6 characters and at least one number. So there's password ABC123. Check pass. So you look in here and it'll test if there is a letter 3 to 6 characters and see if there is one number, where it'll check if there is a non-number looking for 0 or more digits. At least one number. So password. Use lookaheads in the password regex to match passwords that are greater than 5 characters long and have 2 consecutive digits. Okay, so we'll change this here. We'll have a question mark equals. So it wants us to find W3. It wants us to have at least 5 characters. So we'll do 5, comma, and then leaving it open-ended. Then that, so that's one test, and then go ahead. So it'll make a check to make sure there's 5 or more characters. Do a check to make sure that there is And that there is 2 consecutive digits. So D, D. So here. And so I look for a D and then 2. Okay. So would it be /D and then check for 2? D. Gosh dang it. Okay. So should at least be 5 that are greater than 5 characters. So it should be 6 or more. So we did that. 1, 2, 3, 4, 5, 6. Right, 1, 2, 3, 4, 5, 6. And have 2 characters. So should equal that's for 0 or more. And would this be this? So there should be a D, and then followed by, right? Ah, there we go. Okay, so it should have there should be letters, like non-digits. So it should check if there's non-digits and zero or more. So it should have, make sure it's over 6 and that there are digits. Making sure there's 2 digits and more. So this is looking for a non-numerical. So it's looking for non-numerical. And so this is non-numerical, it's looking for a letter. And then it's looking for 0. For more than 2 consecutive digits. Okay. Sometimes we want to check for groups of characters using a regular expression, and to achieve that we use parentheses. If you want to find either penguin or pumpkin in a string, you can use the following regular expressions. Okay, so engu or umpkin, so you can find those. Then check whether the desired string groups are in the test string by using the test method. Okay. Fix the regex so it checks for the names Franklin Roosevelt or Eleanor Roosevelt in a case-sensitive manner. Make concessions for middle names. So okay. So So true for string Eleanor Roosevelt, false for string Franklin Roosevelt, Frank Roosevelt. So oh my god. So we have this. So Franklin or Eleanor, or it should also check for D dot or no one, I guess, cares or knows about her last name. D. Oh, Franklin D. Right, Eleanor, and then Roosevelt. Oh, result would be my string dot test. I thought it was already made. My Regex. Wait, hold on. Oh. My Regex dot test, and then use my string. There we go. So when it looks in here, it'll find Franklin D and then Roosevelt, or it'll find Eleanor Roosevelt, and then it'll return true. Say you want to match a word that occurs multiple times, like in a row, you could use row, but if you don't know the specific word repeat, right, capture groups can be used to find repeated substrings. Capture groups are constructed by enclosing the regex pattern to be captured in the parentheses. In this case, the goal is to capture a word consisting of alphanumeric characters. So the capture group will be, so it's going to find all the numerics characters with a plus, so it gets the full thing of that, full word or consecutive characters, and enclosed by parentheses. So the substring matched by the group is saved to a temporary variable, which can be accessed within the same regex using a backslash and a number of the capture group. Captures are automatically numbered by the position of their opening parentheses left to right, starting at 1. That's it. A string will return an array with the match substring along with its captured. So, oh sheesh. So if we need to match, string that consists of only the same number repeated exactly 3 times, separated by single spaces. So if you don't know the specific word repeat, the goal is to capture a word consisting of the capture. Okay. Okay. Not matches. The group is saved to a temporary variable which can be accessed within the same regex using a backslash and the number of the capture group. Okay, so this right here is like a variable, and then this is like using the first capture, this \1, automatically numbered by the position of their opening parentheses. So this would be row, but then you're doing row, row. And then it prints out which one it captured. Return array with the match substring along with its capture groups. So to do this, we make the parentheses, right? We do the backslash w plus, right? And we want to match it 3 times. Well, we want to get this, right? Because it's a number. So then we repeat it once, repeat it twice, right? So it's technically passed 3 times. So if we do a let match equals repeat num dot match regex. So if we want to do a match, we have to get the string, right? Oh wait. Okay, so this is a string, so we have to use W. Okay, so let's see what this brings. So console.log result with true, and console.log match. So now you're seeing both. So it's getting 3 matches. So you get this one, and then you have repeating right here. Which this is 42. So if you take this out, it'll just make it once, and then it'll say it's 42. So to keep repeating, do 1, 1, and you want to repeat 3 times. To match string that consists of only the same number repeated exactly 3 times separated by single spaces. So if we did 1, it's not true because this one is not repeated 4 times. It's repeated 3, right? And if we take it out, it is repeated twice, so it prints out the 2. But, and this will repeat, see? So you can just see how many times you want to repeat it. And if there is, let's say, you know, if there's more than, you know, the specified repeated numbers or words, then it'll say, no, it's false. So you can design how many times to repeat. But I'm pretty sure there is another way to do this with less syntax, so we can get rid of these. Should not match the string 42, 42, 42. And it shouldn't. What? Your Regex should use a shorthand class. Okay, so it is finding digits. Is it converting? So it's converting these to digits, it looks like. Okay. Should not match the string 42, 42, 42. Okay. So. But. So let's do a console.log result. So we can test this. 42, 42. Okay, so it's basically saying that it's there, but we need to make sure it's exactly this. So, how would we... Capture groups are automatically numbered by the position of their parentheses left to right starting at 1. Match that occurs thrice. Spaces, okay. To match a string that consists of only the same number repeated exactly 3 times separated by single spaces. No. That makes 4. So, no. Okay, so it has to have okay, so we have to so this has 3, but if this has more, it can't. Right. So this is true. But how to make it... Can you do this? Is this a thing? No. So we have to... So how do we make it? So how do you make sure it's... So you're getting this, being the first, being the second, but then it just shows like, oh, they're here, but how do we explicitly tell it that? That's... Wait. Alright. Okay. How is this true? Okay. So do we just do 3? No. Num dot match regex. Yep. Okay, so it only found one. But it's doing this.
Dad?
Yeah.
It's bedtime.
Okay.
Ew.
I love you.
Abby, are you streaming?
Yeah.
Right now?
Yeah. Alright.
Am I on camera?
No.
Mm.
Not until you're older.
Wait, those are your videos?
Mm-hmm. Alright. I'll be right back, guys. I'm gonna tuck the kids into bed. So give me just a second.
That's...
Alright, I'm back. No. I need to make sure this repeats 3 times. And I've already done that. Because we repeat it right here. Gosh darn it. Gosh darn it. Nope. Nope. There. So. And we did it right here. So how is that null now? blank here. So, oh yeah, this makes 4. So this has 3. So this is what we have. Should not match the string. So how do I make it? Does this end? Like if I put an end symbol right there? No, it doesn't end at all. So I found 3. I've got exactly 3. But how do I make it? I'm just gonna have to look. I'm gonna see how. Right. Match only test. Right. So a space with test. Okay. Okay. I think I've got it situated now. So if I do this, and I also put an S, so we do a 2. So we have okay, so we have one that has 42, and then we have a space. Oh yeah, space character, and that'd be 2. Okay. Dang it. So 1 space 2 space. That's a space character though. Ay ay ay. Okay. So how is this false? This is false. But that's true. So right. When I put another space here. Yeah. Yeah. Nope. What? Right, I get that. Yeah. Right. So here. get that. Oh, so we want to make sure, okay. So we want to make sure it's exactly matching here. So do an S character. So this is a space, and you have this, and then you have 2. Right? Because this is 1, this is a space, there's this, 2, 1, and then we want it repeating for how many times? So there's only this. It should only match that. This, this, this. But that's not true. That doesn't equal this exactly at all. How is this true? What are you talking about? I mean, I get it, but at the same time, it's like, what do you... Right. So it has to have... Oh. Yeah, okay. So you can do this and make it G, so it takes these only, but you want to make sure that you declare the beginning and then you declare the end. There you go. So if I do this, could I do the same thing? It's still false. So this has to match exactly 3. So at the beginning it's gonna have this. And do I really need that either? Ah, okay. So we have the beginning here. At the beginning it's gonna have the 42, and then this, and then it's gonna match this. So 1, 2, 3, and then end there. Jeez. Complicated, man. It's so complicated. Searching is useful, however you make search even more powerful when it changes or replaces the text you match. Okay. So we find silver and then we hit replace using the regex and then replace it with blue. Okay. So this is pretty easy. So this is easy, but you can also access capture groups in this specified string with $signs. So CodeCamp replace this, so this word with, you know, a space with this word, okay, and you can replace it with number 2, number 1. So this would replace it with camp code because this is 2 and this is 1. Okay, write a regex fix regex in the string 1, 2, 3, then update the replace text variable to replace 1, 2, 3 with the string 3, 2, 1. Assign the result to the result variable. Make sure you're utilizing capture groups in the replace string using the $sign. Okay, so we're going to get this capture group plus with W plus with another W plus It's really making you think, huh? What? Fix Regex. Change this line. Oh wait. So we can do this. W, right? And then we can get S for the slash space. And so we'll do this. So now we can get 1, 2, and 3, and then we can change this to, right, to 3 to 1. Oh, $sign. There we go. So we have the 1, 2, 3, 3, 2, 1. So everything in here, we just basically took this inside here and then switched it around. So we could put whatever we wanted in here. So replace, you find what you want and then replace it here with string.replace. Okay. So now, sometimes white space characters around strings are not wanted, but are there. Typical processing of strings is to remove the white spaces at the start and end of it. So write a regex and use the appropriate string method. Okay. So we want to get right here all white space at the beginning and at the end, right? I can put this in here, and then I can make another one. That's it. Jigs. Okay, so now we'll get the hello dot trim or prototype dot trim. So the prototype is basically transforming something into a new variable. W S Regex. So trim. So the string Is it just dot trim? Console dot log result. There you go. Hello world. So we trimmed off the beginning space and everything after at the end, I believe. This is the appropriate method to remove white space at the beginning and end of strings. Dot trim will work here, but we'll complete the challenge using regular expressions. Oh! Okay. How would... So we could do this. Okay. So we can do no strings, right? And then no strings at the end. So we could do this all in an expression, right? Yeah. And then no strings at the end. Strings. Strings at the end. Oh wait. So yeah, so we do want to do this. So there's no strings. No strings. So at the beginning, we just want to select plus with no omitting. Okay, so can I do this with, can I do this? So how do I select? With no space at the end. Gosh darn it. Alright, so let's try this. There is So yeah, you could use trim, but we have to select match WS. Okay, so okay, so we want to do beginning. We want a /w less so we can do bum 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 bum. Okay, so here and then we don't want any at the end. No space at the end, so hello, okay, and then we want hello world, so I want to be able to S and then W. Right. How do I get hello world? Okay, so we have that. Okay. Okay, so let's do that. There has to be beginning. Why? Why can't that be a thing? So A through Z, A through Z. Why? Wait, what? So the beginning has to be K, and then we'll do a world. And then okay, W. Yep, I have it, you know, and so it took both of these, right? So okay, so it's supposed to be that, and then we'll have supposed to match. Oh my gosh. You know what? We can. So can we do a Regex is one of the most complicated things. So if we can grab hello. So can we do so there's hello. And then W. Gosh darn it. Oh, it's so hard. So So, could I add? I could add all of these. Ah. So I could do a replace. Ah, hold on. So I can do this. Right? And then we'll do this. I'm genius status. So we're going to get rid of this and S, right? Okay, so now we can do it. And then, so we get this at the beginning. 0. So we get that. But how do we get the end? It just gets the end. It doesn't get the beginning. Oh my gosh. Okay, so let's just take this hello dot replace, and we'll take WS Regex and replace it with this. Damn it. I just need the ending. If there is a space. No, it's still, oh my gosh. Oh my god. I'm trying to trim it, man. I am really trying. How do they trim this? Substrings at the end. Substring. think I found the solution. Okay, so here, we will do this. At the beginning, if there's space, we will make this 0. 2. Until we hit the H. And then we're going to put an I. So, no, that's not what I wanted to do. The spaces. I want to get the spaces. I want to get 1, 0 to whatever before we hit the H. Why did it grab the... It was supposed to take the... Selecting a substring. Okay. Or... this... S 0 Oh my gosh. Do I put this? Like, does this work? Like, how? Why does it get rid of the H? That's what I don't understand. Okay, hold on. I would imagine. Okay, hold on. Maybe it's after this. Oh my gosh. It should be equal to hello world. Wait. No, there's nothing at the end. Oh my god. Why is there space at the end? No. Oh my god. Okay. I just don't understand where... this is coming from. Okay, hold on. Okay. At the beginning, right? All right. And okay, at the end, oh my god, just I am just at a loss. Right. Space plus at the beginning. Space plus at the end. G. Oh my god, I was so close. You got, oh my gosh, guys. Okay. So, spaces at the beginning or spaces at the end. Don't even need this. So, yeah, because at the end there's still that one thing. So how do we? Slash S. No. I have to figure this out. So we got this at the beginning, and everything after at the beginning, or plus at the end. Ah. And anywhere this occurs. So if there's multiple at the end or beginning, we'll get rid of it. Oh. So that took longer than it needed to be, and it was a lot harder than it needed to be, but that is regex, or regular expressions. So you can replace easy, you can search easy, but it is not, the syntax is not is not the easiest. I will say that. This took there was like a couple project, like little programs in there that we had to do, but this was by far one of the hardest lessons I think we have done. Was regex, and I knew regex was not going to be easy. Oh man, holy crap, that was just nuts. Okay. Oh man. Okay. Alright. Well guys, that was regular expressions. we are done that. Hold on, I have to run a test and I have to submit. But yeah, we have finally completed that. So, mind you, that was probably the hardest thing out of everything. Debugging has 12. The next time we come back, debugging has 12 steps, and debugging is relatively easy. It's one of the most important things that you can have. But I mean, going from something that hard to this light was is going to be amazing. But yeah, my head hurts from trying to have to, really dig in and think on this. But yeah, that's just all part of learning. Is trying to, keep trying it yourself until you really can't anymore, and then, try to look for resources and, ask peers, and that sort of helps. So looking at the hints did help, and we were getting there. We were very close. And, obviously if this was a problem that would last more, like a while, you'd have more time and you'd have to, get this completed. But yeah, trying to do this within the stream, like, one, I want to make this as easy as possible for you guys, and myself. But sometimes you get problems like this where it just throws a whole curveball. So yeah, if you were basically having a hard time catching on to some of that, I mean, that is definitely fine. I mean, it's a hard thing, and I would highly recommend practicing it. Like, even though it sucks, I would definitely, look into seeing what more problems you could probably solve until you start getting better at it. That's just my thing for you guys. But yeah, when we come back, we'll get back into debugging. And that, like I said, that lasted way longer than it should have. But thank most of you guys for staying through. I know some of you guys were not expecting it to be this long either, but it just happened. So, alright, you guys have a good night. I'll see you projecting in a couple days, to have like a pretty light session. Debugging, like I said, is nothing. It just helps prevent syntax errors and, how to debug programs and prevent common issues before they happen. So, alright. Have a good night.